Hey everyone. So in this video we will be talking about two different things. The first part is talking about an application of neural network that is seemingly extremely creative, even borderline magical, so to speak, at least from my perspective. And the second part will deal with something that even the neural networks cannot achieve or haven't achieved yet, to be precise. So talking about the first half of this video, the application that I would like to bring to your attention is adding sound to silent films. Now, giving you a bit of context and some technical information regarding this. This was done by researchers Ghose and Prevost. They created an algorithm which could automatically add sound to movies by means of the Foley process. Now, Foley is the art of adding everyday sounds to movies, videos, to mainstream media, etc. Basically, and of course, all of this is done artificially. Now, how they did this is in the following 4 steps. Step number 1 is deciding on 12 different movie events, such as gunshots, footsteps, the sound of rain, and they recorded 1,000 of these videos with an average clip of 5 seconds, of course all silent in nature. Then they were talking about how to classify these clips into these 12 different movie events. Now this was done by 2 models. These 2 models were of course compared, their performance was compared. But this was frame sequence network versus the frame relation network. Now this was done to, as I said, classify these videos into these 12 different events, which brings me to step number 3. How exactly was this made possible? So this is something that would be more familiar for those of you who have a bit of experience in convolutional neural networks. This was done by the ResNet 50 CNNs. And how was this done? Now these ResNet 50 CNNs were used to extract these movie features. And this was done by, of course, extracting the images by adding granularity and extracting these features from, of course, the frames of these videos. And then once this was done, then comes our final part, the generation of sounds. Now this generation of sound was done using inverse short time Fourier transformation method. And now how were the final results achieved? This was done by putting it to vote in front of college students, and this algorithm, which of course also used the LSTM, long short term memory, this algorithm got the popularity vote from around 65% in one model to around 73% in another model. Which basically means that around 65 to 73% of people preferred this synthetically added sounds as compared to the original sound of these videos. Now, why is this seemingly magical? Because while you might think that, oh, it's just adding sounds to these particular movie frames, I think it is magical because it is not far-fetched to think that one day these algorithms would be able to tell stories, entire stories based on paintings from, let's say, the Renaissance area or the medieval age, or maybe analyzing handwritten letters and telling you the story behind it. And I think that's pretty much possible in, let's say, a few years or maybe a decade down the line. Now, while this application in particular might fool your senses, there is something that even these powerful neural networks cannot do, and that is reasoning. Now this reasoning of course deals with a lot of certain factors, which some of them could be, let's say, analyzing root causes, which are very, very human in nature, or the subtlety of and the implication made in speeches. That's something that we humans are trained to recognize. Our brain has had the training time for almost 20 years, 21 years as is my case, and it only will increase with time, and that's a luxury that these networks unfortunately cannot have. And the best example to prove my point is IBM's Project Debater. Now, props to team IBM. They have created such a masterpiece, and I'm saying that because I am a budding engineer and a debater. So for me, seeing Project Debater compete against a real human, it was an out of this world experience, to say the least. But if we analyze the arguments made by Project Debater and Harish Natarajan, then we will notice that Project Debater's points were more of statistical nature, were more research oriented, dealt with numbers and figures, and maybe quotes by eminent figures. Whereas on the flip side, Harish Natarajan's points were more analytical in the intangible sense, something that only a human can know. No animal, no machine can possibly make these inferences without, of course, having the brain of a human. And that is the difference between the machine and a human. That's what I want to say, that this particular application is very, very far-fetched, if not completely unrealistic in nature. And that is something that I personally believe that machines might not be able to achieve, although I would be the happiest person alive if that becomes possible in the near or the far future. And with that, I would like to end this video. Thank you so much.